This part of the development length portion of the code is complicated enough that I wanted to devote a separate video just to this 9.7.3.5. It basically has to do with the shear provisions for bar cutoffs. Let me explain what's going on. Cutting a flexural bar, so the long steel, affects the shear strength. It's kind of weird. So if you cut a moment bar, you are affecting the shear strength. And we have dramatic proof of that in our own structures lab. I used to not believe this. So the argument is that when you cut one of the bars, bars off, you dramatically change the tension force in the reinforcement, and therefore you're dramatically changing the moment, what's happening in the moment. So you have a sudden change in T, and since moment is T times Z, you have a sudden change in the moment capacity. This is a part that's hard for me to understand. So they're saying that a sudden change in this moment capacity is a change in moment over a short distance, and the slope of a moment diagram is shear. So it's putting an increased shear demand on there. But the shear at any point is just a shear at any point. So that argument never made sense to me. The shear diagram is a shear diagram. What you do to the inside of the beam doesn't affect the shear diagram. But what you are doing inside the beam by cutting that beam and causing this drastic change in tension force, you are making some concentrations, and you are affecting the shear strength. But anyway, for a long time I didn't believe this, and I was mentioning this to Charlie Dolan when I first moved here to Wyoming, and then he told me a story that actually made me feel a little bit better, that he also was a little skeptical of this. And so whenever you cut a bar in tension, because of this extra shear loading or what's going on, you should put extra stirrups in the beam wherever you cut a bar to give it more shear strength. And I just thought that was crazy. You know, the shear is the shear, and if you just make sure Vn is greater than Vvn is greater than Vu, you're good. You wouldn't need these extra stirrups. So Dr. Dolan had this long beam, and where they cut the bar, they did not have these extra stirrups because of the thinking I just mentioned. And sure enough, in the lab, right at where those bars were cut, there was a sudden shear failure in this really long, I think it was 60-foot beam that he was testing for the Navy. And it was a T-beam, and it failed in shear, and it shot part of the slab up to the ceiling of the structures lab, if you've ever been in there. It was pretty scary. Anyway, this is a real thing. When you terminate a bar that's in tension, you induce extra shear load, and so you need to make sure you have adequate shear strength, either excess strength or you have to put in extra stirrups. So back to the provision in the code. If you're cutting a flexural bar that's in tension, which all bars are usually in tension, so if you're cutting it in tension, you have to meet one of these three things here. Okay? Let's look at these one at a time and see what they mean. Okay? So the first one, Vu less than 2/3 phi Vn. That's the same as phi Vn. Okay, that's the shear strength, is greater than 1.5 Vu. If you have 50% more shear strength than you need, you're good. Okay, you should be covered. The jump in shear load by terminating the bars is not 50%. Okay, AV has to be greater than the required amount plus 60 BD equivalent. That should have been a subscript, sorry. Okay, so you have to put in these extra stirrups I'm talking about from the cutoff point, so where you cut the bar, to 3/4 D. So this was the bar. Okay. Cut that off. You need extra stirrups here over 3/4 D. Okay. These extra stirrups must be 60 BS over FY. Remember, min stirrups were 50 BS over FY, so this is even more than min stirrups. S must be less than D over 8 beta. And so remember, S max for normal shear is D over 2. D divided by 8 beta, where beta is the ratio of the cut bars to the total bars. If you don't meet the other two requirements, you can always do this, and this is what you usually have to do. You have to put extra stirrups according to this equation right here. Okay. And the last of the three provisions is this: VU less than 3/4 phi VN and MU less than 1/2 phi MN. If you flip it around, phi VN has to be 1.33 greater than 1.33 VU. You have to have 33% extra shear strength. Okay, the VN is 33% more than you need, and phi MN is more than double of what you need. So those two will make it safe. Okay, so again, you have to have one of these three things happen: 50% more shear strength, or 1/3 more shear strength plus double your moment strength. And if you can't meet those two, then you have to add extra stirrups according to this provision. So this is what ACI 9.7.3.5 is all about. And believe me, this is a real thing.